Good afternoon, everybody, and welcome to the SEHSC Contest, a short course, the second online section. My name is Marcelo Valal. I'm the Forage Extension Specialist at the University of Florida, and I'll be your host today. Thanks everybody for joining us. So this event is a collaboration between the Cooperative Extension, the SEHSC Contest, and Massey Ferguson. We count with the sponsorship of multiple partners like Mayo Ag Services, Hobo Tractor, Florida Gateway, Purina Farmers Cooperative, Farm Credit of Florida, Cortiva AgriScience, Cardin Insurance, AgriKing, Key to Profit. I'd like to have a special thanks for our committee that has worked to put this program together. Paulette Tomlinson with the extension at UF, Mark Malding with UF FIFA's extension, Ashley Kuhn with our Forage team, Dr. Lisa Baxter at UGA, Dr. Leanne Dillard in Auburn, and Ash Alt from Massey Ferguson. So a few housekeeping before we get started here. We'll have two presentations today. Those presentations, we're going to introduce the presenters just prior to their presentations. Please keep your microphones muted at all times. If you had not done anything, it should be okay, because once you connect, it should be muted. This event is being recorded, so our colleagues that cannot see today can check it later on. We'll have question and answer section after each of the talks. There are two ways you can ask your questions. You can either type it on chat and I'll read them aloud, or you can raise your hand. There is a feature on Zoom that you can raise your hand, or you can type your name on chat and I'll call you so you can unmute yourself and ask the question. One important thing that I forgot mentioning our last meeting a week ago is that we have a quick survey just to make sure we're on track, we're offering the programs you need. The survey should take no more than 2 minutes to complete. Once you log out from the Zoom, the survey is going to pop up on your screen and you can complete it. Please leave your feedback and your comments. Okay, today's talk is going to be presented by Sunbelt Ag Expo and the SEHSC Contest, the promoters of this event. And for that, I welcome Chip Blalock to join us and explain a little bit about how this partnership works between Sunbelt and the SEHSC Contest. Chip, welcome.
You bet. Thank you, Marcelo. Thank you for the time on the program today, and thank you for all that you and the committee do to make the SEHSC Contest happen year after year. And the hay contest for 2021 is winding down with a deadline for submitting hay samples coming up next Wednesday, September the 1st. And as always, the award winners will again be announced on the first day of the Sunbelt Ag Expo on October 19th at the opening ceremonies, which start at 9:30. Hay contest awards usually come off about 9:45, 9:50 in that time frame. And it's always a big event. It's a chance for us to honor more of our producers, and that'll be held right there next to the Livestock Pavilion in the R.W. Griffin building. After having a year off and having to cancel because of COVID, we are just so excited to be hosting an in-person Sunbelt Ag Expo on October the 19th through the 21st. Our exhibitors are definitely ready for an in-person show, as well as our farmers and attendees. We will have demonstrations on our research farm, cotton and peanut harvesting, and the hay demos in the fields, as well as the Chevy and Ram commercial test tracks in the exhibit area. We're also full steam ahead with our demonstrations in beef cattle and forage, where we work with the SEHSC Contest Committee on those also, in dairy, the equine demos with clinician Bill Craven and trick rider Annalise Granger, fish ponds, hydroponics, sheep and goats, poultry, and we partner with the extension specialists in Georgia, Florida, and Alabama to put these seminars and demonstrations on. In addition to that, we'll have the Youth Educational Challenges, Ag Advocacy Contest, a new initiative for Georgia Farm Bureau, and they will soon be partnering with Alpha and the Florida Farm Bureau, Ag Mechanics Contest with Farm Credit, and the Georgia State FFA tractor driving contest will happen this year. We're looking forward to kicking back off the Flint River Fresh backyard gardening section, the stock dog trial, the antique tractors, and the Young Farmer Q Fest and the Young Farmer Barbecue Cook-Off. We're really excited to celebrate the 31st anniversary of the Swisher Sunbelt Expo Southeastern Farmer of the Year program. We just went on the judging tour last week, and the winner of the Swisher Sunbelt Expo Southeastern Farmer of the Year will be announced at the Expo luncheon at noon on October the 19th. So whether it's row crops, hay, irrigation, livestock, poultry, fish ponds, backyard gardening, ATVs, hunting and fishing, automobiles, antique tractors, stock dogs, we truly have something for the entire family and the latest technology for the farmers in the region from throughout the country to come and see and experience, gather information to take back their operations to enhance their economic and environmental sustainability. We look forward to seeing y'all in Moultrie on October 19th through the 21st for the 43rd annual Sunbelt Ag Expo. In the meantime, keep up with us on Facebook, Instagram, and Twitter. Visit sunbeltexpo.com for the latest updates on contest special events and the youth educational opportunities. The sunbeltexpo.com will be the avenue to gather information such as maps and schedules and events going on throughout the 3 days of the expo. So y'all check that out. We'll have our show program on sunbeltexpo.com. And we're just real excited to wrap up the hay contest this week, get those samples tested in the next month and get the plaques ordered and prize money distributed and ready to go on October the 19th at our opening ceremonies when we honor 7 category winners in the Southeast Hay Contest and the overall winner in the hay contest. Again, thanks, Marcelo. Hope y'all have a great evening. And thank you for the foresight to putting on this virtual series and culminating it next week with an in-person meeting. Thanks a bunch, y'all.
Thank you, Chip. And yes, we are all excited to be back at Sunbelt. So for those that don't know, last year, Sunbelt was canceled. So the Southeast Hay Contest award ceremony was held along with the American Grass and Forage Council meeting in Savannah, Georgia in January. But we're excited to be back at Sunbelt, and it's a great partnership of this educational program that is ever expanding. So let's get to our talks of the day. So the topic of today is tools on hay production, weather forecasting tools, and inoculants. And I'm going to introduce our first speaker. If my slides can go ahead, here we go. So David Zierden is a Florida State climatologist at the Center for Oceanic and Atmospheric Prediction Studies. And his the primary work focuses on historical climate observations, trends, and variability, and how those climatic and weather forecast tools can link to agricultural, forestry, and water resources. So I asked David to talk a little bit about weather forecasting tools in hay production. And this is something we all need because we're always trying to find the weather to get some hay cut. David, I'm going to stop sharing here and you're good to go.
Okay, yeah, thank you very much, Marcelo. I'm very pleased to be with the hay short course this evening. Let me go ahead and share my screen and make sure we can do this seamlessly. Are we up and running? Okay, great. As Dr. Valau said, he asked me today to talk about reliable sources, tools, resources for weather and climate information. So this is kind of a new talk for me, but it was great to put this together. What I'm going to show you this evening is not an exhaustive list, but these are the tools and resources that I use just about every day in what I do, and that I find to be the most reliable and the best information out there. And just for the record, the Groundhog and the Farmer's Almanac, I'm not sure they qualify as reliable sources. So we'll go ahead and get started, and a brief overview of what I'm going to cover today. I'm going to begin with a little background on the science of climate and weather prediction to kind of for some background. Then I'm going to go into what we call weather forecasting, the short-term weather forecast, 1 to 10 days out. Also very topical now is the prediction of hurricanes, tropical storms, and other tropical weather. Then I'm going to go over some tools and resources for monitoring recent weather and climate, rainfall, temperature, what's gone on in the last 1, 3 months, 12 months. And then we'll wrap up with looking at climate predictions, seasonal climate predictions, and what they're based on and their reliability. So with that, I'll go ahead and get started. First, kind of a state of the science, and this is a great graphic that really kind of illustrates where the science is when it comes to the accuracy and skill of predictions. Again, from the 1 to 10 day or even 2-week time frame, we call that weather prediction, and the skill and accuracy is very good for the first few days, 1 to 3 days out. In the 5 to 7 day time frame, accuracy starts to fall off and the skill starts to fall off. And by the time we get out to 2 weeks or 3 weeks, these weather forecast models and weather forecasting, due to the chaotic nature of our atmosphere, really have very little to no skill at all. The next time frame is shown in red, and it was what we call subseasonal, from 2 or 3 weeks out to a month or two. And this is kind of a blind spot in the science where there really is not a lot of skill, even in any season of the year, for that 2-week to 2-month time frame. And then the last horizon we call seasonal forecast, which is basically 1 to 12 months or more out. And you'll notice a little bit of an increase in skill there. And one of the biggest tools we look at for the seasonal forecast is the El Nino La Nina cycle, which has a big impact here in the Southeast United States, especially during the cold weather months, November through March or April, when we have one of these El Nino or La Nina events in the Pacific Ocean. Kind of a difference. Weather forecasts look at the current features, low pressure systems, air masses, cold fronts, and their movement and what they're doing, where the climate forecasts look for recurring patterns. And I'll talk a little bit more about that on the next slide. So what are the tools we have for weather and climate prediction? Well, the primary tools are these computer weather models, or known as numerical weather prediction. Numerical weather prediction has roots back at the beginning of the 20th century, but we didn't have computers back then, and the computations involved were just precluded any real-time weather forecast using these mathematical equations or the physics that we know about. However, numerical weather prediction or modeling was one of the first peacetime uses for the first computer, the ENIAC. And so it's grown ever since then. And the way these weather models work is we parse up the atmosphere into a grid, both horizontally, vertically, and up throughout the atmosphere. And at every grid point, this set of equations is solved, known as the primitive equations. And that's where all the physics lies. It's the usual Newtonian: force equals mass times acceleration, the continuity equation or conservation of mass, conservation of energy, the natural gas law, and also the Clausius-Clapeyron equations. And I kind of have them listed there. They look short and simple enough, but the devils are in the details, and each one of those terms is infinitely complicated to both get observations for and to solve in these very complex computer models. The weather modeling is weather modeling that 1 day to 2 week time frame, highly dependent on initial conditions. So there's a network of upper air or weather balloon stations around the world that twice a day at the same time, 0 hours Greenwich Mean Time and 12 hours Greenwich Mean Time, take these weather balloon samples of the complete atmospheric column, temperature, winds, humidity. We also have surface observations, satellite observations, airplane and ship observations that all go into the initial conditions for these weather prediction models. Now, climate models are a little different. They use the same physics, but because instead of running for 10 days or 14 days, they run for 100 years or more. So the physics have to be simplified in the climate models. The resolution has to be reduced. And the climate models rely more on forcing to get changes in the general patterns than they do initial conditions. So let's talk about a little bit about how weather forecasts are made. And over here on the left is a picture of Ginger Z, who is the chief meteorologist for Good Morning America. She is highly educated, highly trained, very competent scientist and weather forecaster. She is not a weather girl, nor are the vast majority of those we see in broadcast TV. So that kind of gets my feathers ruffled when I hear the term weather girl. But the forecasting process, it begins with a close look at the current conditions, looking at the upper air and surface observations, satellite data, radar data. Then they look at the different computer models and look at the output from these computer models. And not all the models handle the situation the same way. So they have to be able to judge which one has a better handle on the current situation. They look for which model is more consistent from run to run, which one is more reliable for that particular region or that current season. And then also very important is the use of local knowledge of the topography, the weather patterns, the climate of an area to adjust or fine tune what the computer models are telling us. So all that goes into the daily forecasts we see from the National Weather Service or on broadcast TV and radio. So let's go into some of the resources for receiving weather information, weather and climate forecast. This is kind of a touchy subject for us in the meteorology field, and that's the smartphone weather apps. In fact, some in our field even call them crap apps. Not that they're completely useless, don't get me wrong, but there are some common problems. They're good for showing the current conditions, but it's hard to know what weather station they're pulling those from, how near it is, how representative it might be to your particular field or location. Over on the left, this is actually a fun one. There's a weather app called Carrot Weather, where the weather information is actually very sound. It relies on dark sky, but the interface, they give you a lot of fun messages, like they show here, Sharknado conditions for Butterfield, Kansas on this particular day. So it's kind of a fun app, but the weather information is very sound. But these apps can also have a false precision to give you the exact forecast for your exact location, your address or street number. They simply downscale the direct model output without any interpretation from the actual forecaster or any other considerations. So kind of a false precision. And on the bottom, you can see the forecast is for 87% chance of rain at 11 o'clock, going up to 89% by 1 o'clock. That we don't have that kind of precision in weather forecasting. And again, there's no local expertise behind these weather apps. But there are some very useful apps out there. Those with weather alerts. We used to be urged to everyone have a NOAA weather radio with the alerts on so we can be awoken or alerted when there's severe storms, tornadoes in the area. Well, those NOAA weather radios just sit on your dresser. Your smartphone is with most people almost 24 hours a day. So the weather alerts on a smartphone is a great way to receive them. everyone should have weather radar information on their smartphone. Radar Scope is a private app that costs a little bit of money, but it's by far the highest quality in the industry. NOAA does have their own Weather Radar Live app that is free, but it's not as high resolution and not quite the quality of Radar Scope. Weather Channel is a great app. It's good for the big overall picture, but it still lacks local expertise. And again, Dark Sky and Carrot Weather are some that are pretty good. But again, none of these give you that local forecaster that really knows the area and has evaluated the different models. So we'll go on to the gold standard, and that's your local National Weather Service forecast office. And on the bottom left, you see there's 122 weather forecast offices around the country. In our area, it's in Tallahassee, Florida, co-located with FSU Meteorology Department. The National Weather Service is the gold standard, one, because they're the ones who collect all the data, the surface observations, the weather balloon data, the weather radar. They're the ones that administer all of that, along with the weather forecast models. And they're staffed 24 hours by highly trained professionals. They're operationally give forecasts 4 times a day, often updated in changing weather. And all these offices really provide that local knowledge and local expertise to fine tune the forecasts. And I certainly don't have time to go over all the forecast products from the National Weather Service. And let me also say, the best way to access the National Weather Service forecast is either online through their website or the NOAA weather radio. However, most broadcast meteorologists rely heavily on the National Weather Service forecast. So you're often getting the exact same story from the broadcast meteorologist. But the products are really too numerous to go over right now. Anything from marine weather to fire weather to our daily forecast. But some products that really have a lot of use is they've gone to a gridded forecast system where the temperature, rainfall, humidity is all forecast on a 1 kilometer grid. That map in the middle shows the high temperature forecast for today. You see some of the cities highlighted, but also you see the shades of orange and yellow where they've really fine-tuned this due to topography and just different weather features. And also through this interface, by clicking on any location from that grid, you can get the hourly forecast out for 3 days of temperature, humidity, winds, chances of rain, chances of thunderstorms. So this is really the most state-of-the-art and reliable weather forecast available right now. One other thing is if you hunt around and look for the daily forecasters discussion, it really gives you a couple paragraphs of what they're looking at and their reasoning behind the forecast. It can be fairly technical, but once you start reading them, you get used to the jargon. Broadcast meteorologist, also a very reliable source in most markets. Most markets these days have degreed and trained meteorologists giving their weather forecast. They rely heavily on the National Weather Service, but other larger markets, they do a lot of their own forecasting, looking at the same weather models and satellite and radar, but putting their own picture together. The kind of the highest tier is when the broadcast meteorologist has been certified by the American Meteorological Society. But also they're often the most trusted source in the area. Folks that have been doing it for decades, like James Spann in the Birmingham area, Mike McCall down here in the Tallahassee area, one of the most trusted voices in weather. So now we'll switch gears a little bit to tropical forecasting, hurricanes and tropical storms. And again, I'll start with a pet peeve, and that's when somebody calls my attention to spaghetti models. Okay, these are highly complex atmospheric models that are coupled with the ocean. We're not modeling pasta. And often I'll get questions from friends and family. Well, these are the different model projections for the track of the now tropical storm Ida in the Caribbean. And you see there is a spread. We're lucky with this situation. It's a little more tightly clustered than some other storms in the past. But they'll ask me, well, which of these models is the best? And, well, it depends. You know, two of the best models are the European model, the ECMWF, and NOAA's GFS are two of the most reliable. But it depends on the situation, which model is handling the current situation, the overall pattern, the run-to-run consistency the best. And I don't have the expertise to figure that out. But the guys at the professionals at the National Hurricane Center do, and they look very closely at all that. So all this is taken into consideration in their official forecast. Another pet peeve is, especially on social media, some weather folks will show a single model run for 7 to 10 days out that all of a sudden shows a tropical system in the Gulf. Well, there's not much predictability at 7 to 10 days out, and it needs to be taken with a grain of salt. The next run of the model could show nothing at all. So that's another pet peeve of mine. And also there's a lot more uncertainty in these model projections before the system is fully formed and organized. Over the years, recent years, the hurricane and tropical storm track forecasts have improved greatly. The forecast cone gets tighter and tighter each year. However, the forecast intensity or how strong the storm will become is still a challenge. So again, touting the professionals at the National Hurricane Center, staffed and operational 24 hours. Again, I don't have any secret model, intuition, or data that they have not already considered. So I'm not going to do any better than their forecast. And also all the reputable media, emergency response, all follow their lead very closely, because it would be very counterproductive to have mixed signals going out when forecasting the track or the intensity of a storm. And the forecasts go out to 5 days, no longer, because we really don't lack the accuracy or skill in the science currently. Some of the most useful products I show on the top left is the tropical outlook that shows the areas that they're really paying close attention to, and they even give a probability of development. And then, of course, the actual advisories once a storm has formed, like I show on the bottom left for Tropical Storm Ida. And once again, you can also read the forecaster's discussion at the National Hurricane Center, which really provides the details and the reasoning behind their forecast. Here's another product that I think everyone here would find very, very useful. And most weather forecasts give a probability of rainfall, but not so much information on the amount that's expected. Well, the National Weather Service Weather Prediction Center produces these, what we call quantitative precipitation forecasts that actually give possible amounts from 1 to 7 days out. And over here on the left, I show the 7-day accumulation for the next 7 days, the forecast from this National Weather Service product. And you can clearly see the track of Tropical Storm Ida, very heavy rain forecast for the Louisiana coast, lesser amounts for the Western United States. So this is a very useful product. I show the 7-day accumulations here, but you can also get daily accumulations for 1 to 7 days out. A couple caveats with this product: it's more a forecast of rainfall potential. Local amounts may vary, and this forecast is based mostly on one model, the NOAA GFS. So if there's disagreement above models, this product really doesn't show that. So now let's shift gears and talk about where to get information on recent weather rather than forecast weather. And again, this is a product I use every day, a resource, and it's rainfall estimated totals using the NEXRAD radar network. And you can get daily totals from just the past day or accumulations from 1 to 30 days, 60 days, even out for the past year and further back in their archives. And these are radar-based estimates, but they have been bias adjusted by ground observations. So it's really one of the best high resolution rainfall products that you could get. Here we see the rainfall from yesterday where Jackson County and in the tri-state area of Florida got a lot of rainfall, over 2 inches in some spots, where the cities of Tallahassee and Dothan received very little or no rainfall at all. So this can really show you when one side of the county's gotten abundant rainfall one day, the other side left dry. On all these, I've provided the links of where to find these tools and resources. Another product that we're very involved in is the U.S. Drought Monitor. It's a weekly assessment of drought conditions across the United States, and you can even drill down to the county level. It is a blend of short-term and long-term indicators, along with some subjective input from experts across the nation, including a group I coordinate in Florida with National Weather Service offices and the water management districts. So all that goes into this weekly map. Again, some limitations because it's both long-term and short-term drought considered in one map. It may be slow to react to quickly changing conditions. And that can be very problematic, especially with the USDA Range and Pasture Disaster Assistance Program, which is based on this US Drought Monitor product. But again, the Drought Monitor doesn't necessarily react quickly enough to get these quickly occurring droughts that can affect production. Another tool that I find very useful is called Climate Perspectives from the Southeast Regional Climate Center. Again, I have the URL listed right there. There, station by station, you can look at recent rainfall and temperature and compare it to historical context. How does it compare to last year or the long-term average? And over here on the left, I just show a map of temperatures from June 1st through today and how they compare to the long-term average. And we see this summer's actually been a little cooler through a lot of North Alabama, North Georgia, even down into North Florida. It's actually been a little cooler than normal, which has been really a welcome change, and due to all the rainy conditions we've had this summer. And last, we'll wrap up with agroclimate.org, which is administered by Dr. Clyde Fraze at the University of Florida. This uses the same weather station data, but also pulls from the Georgia Agricultural Weather Network and FAWN, the Florida Agricultural Weather Network. And it gives some of the same information on past rainfall and temperature, but also a lot of useful tools and quantities for growers. For instance, like growing degree days. Here on the bottom right, it just shows the growing degree day accumulations since April 1st for Gadsden County, Florida, the Quincy Weather Station. And we see growing degree days are actually a little below average this year due to the cooler temperatures. So I don't have time to go into all the helpful tools and products on agroclimate, but I would recommend checking it out and talking with Dr. Fraze if you have any questions. So I'm going to close with going into climate forecasting, which is a little different thing than weather forecast. The state-of-the-art climate forecasting is available through the National Weather Service Climate Prediction Center. And again, I have the URL listed there. And they provide probabilistic forecasts for temperature and precipitation anywhere from 6 to 10 days out to 13 months out. And on the next slide, I'll go into a little more detail on what I mean by probabilistic forecast. They also provide forecast and a monthly discussion on the supporting data, especially the state of the Pacific Ocean and the phase of the El Nino La Nina cycle. And they also provide monthly and seasonal drought outlooks, like I show over here on the left on the front page of their website. So we'll take a closer look, and this is the seasonal outlook for the 3-month time period of September, October, November of this year. And we have temperature on the left and precipitation over on the right. And it looks, looking at the temperature map, it looks like, oh, everything shaded in orange is going to be warmer than normal. Well, that's not the correct way to read this product. What it is, it's a shift in probabilities. That white area that says EC, or equal chances, that's kind of right in line with the baseline, where the historical distribution, 33% of the time we're above normal, 33% we're near normal, and 33% of the time we're below normal. This shows a shift in those probabilities, where that orange area over the desert Southwest, now instead of a 33% chance of above normal temperatures for that 3-month period, it's now a 50% chance of above normal temperatures. So nearly twice as likely that we'll see above normal, but it's not a slam dunk. And over on the right is the precipitation forecast, where there's generally less skill in these outlooks, especially during the summer and warm weather months. And that's reflected as the whole eastern United States really doesn't show a strong forecast at all. They're just sticking with the baseline of equal chances. But there is more skill at certain times of the year, especially the winter months, November through March, especially when there is a moderate to strong El Nino or La Nina event in the Pacific Ocean that we can really base the forecast on. Another big factor, especially for the temperature forecast, is just the changing climate, because this last decade has been by far the warmest decade in history in the United States. These temperature forecasts are highly tilted towards above normal temperatures rather than below normal temperatures. So with that, I'll go ahead and wrap up some take-home messages. Weather and climate prediction, extremely complicated problem, requires very sophisticated computer models, and massive data and observations to go into these models as tools. Good forecasting uses the models as a tool, but also requires local knowledge and expertise. And there are many private weather services across the country that rely heavily on the National Weather Service data and modeling. But the National Weather Service, in my opinion, is still the backbone of US weather and climate monitoring and prediction. And of course, what I've stressed over and over again, a good weather and climate forecast incorporate local knowledge, expert model evaluation, and they tailor the delivery of the forecast to the needs of the users. So with that, I think I've wrapped it up, and I'll be glad to take any questions.
Perfect, David. Thank you for the presentation. Fantastic. If you'd like to unshare your screen, or if you want to show anything through the questions. So I'd like to open the questions here. If there is anybody, please send me a message on chat here or raise your hand if you have a question. I'm very curious. I like weather forecast, and actually, I remember when I was younger at the farm in Brazil, my dad would radio us into town because phone would not work, and ask me to go to the internet and look at weather forecasts for the week, to give him some prediction. So it was always interesting. So I grew up with that concept of check the weather. Maybe he would call even twice a day, like, Dad, I already told you that, but it didn't change anything. So from a producer perspective, and we're looking into try to get some hay cut. We're not sure if you are going to be ready or not, but we need to get the machines in the field soon and prepare. What is a reliable tool, easy to use, that does not require a high level of meteorological knowledge, that we can recommend for the producers to use for this short-term forecast for agricultural activities?
Yeah, again, going straight to the National Weather Service webpage, you click on your location and it'll give you a very simple day-by-day forecast for the next 5 to 7 days, which you can dig deeper and go into the gridded forecast, but that's not really necessary. It'll give you a good idea of when rain chances are higher, or when they might be forecasting a nice extended dry period that would be good for cutting. So the Weather Service would be the first stop. Other private providers like the Weather Channel, they do a fairly good job and provide fairly good forecasts, again, out to 7 days or even longer. But again, the Weather Channel doesn't quite have the local expertise of the National Weather Service or your local broadcast meteorologist. Also, the Climate Prediction Center has a couple products where they forecast out 6 to 10 days or 8 to 14 days, which again doesn't give you amounts of rainfall or kind of the daily weather, but it can give you a heads up on the larger pattern and when we could anticipate a wet period or a dry period.
Perfect. Yeah. Dr. Romero here has a question. What changes in precipitation patterns we're observing in the eastern United States from a historical perspective?
That's a great question. In the last 10 years or so, we are seeing a wetter eastern United States and a drier western United States. I only showed the regional drought monitor map, but if you looked at the national one, the western US has been in a multi-year drought now. And we all know the wildfire situation is going to be pretty dire this year. So that's kind of been a trend we've seen, a wetter eastern United States, drier western United States.
Right. So I just want to let everybody know I'm sharing here some links on chat, and I'll ask David to, if you don't mind sharing the presentation with me, I can copy those links and email and send through email for those that were not able to copy those links. They're kind of complicated. I'm trying to get here. I put the weather, the weather.gov. There is another one that I like. It's not so easy to interpret. That's the model for the forecast model graphics. I just find them pretty interesting when you get to see all those charts.
Yeah, no, those are all great resources. Yeah, and absolutely, I'll be glad to share the slides that I presented today.
Okay, and another resource here is the weather. Is the 3-month outlook, yep. Because another topic we've been discussing a lot, David, is it's coming planting season for the cool season forages, mid-October, mid-November. So we need moisture to get those forages on the ground. So that chart those maps you shared with temperature and precipitation are important for us to monitor from now on to see how we're going to plan our winter feeding program.
Yeah, to go into a little more detail about that question about the planting of winter forage is typically when we have La Nina conditions in the Pacific Ocean or colder than normal ocean temperatures in the Pacific, it usually leads to a warmer and drier winter season, fall and winter here in the Southeast, which can be problematic for the winter forages. We were in La Nina conditions last year, but we didn't follow the typical pattern. We actually had a mostly wet winter. So this year, it looks like it's looking possible to return for a second year of La Nina conditions. Whether that'll bring us a warm and dry winter, the chances are better, but after last year, it's certainly not a given.
Perfect. Well, if I don't have any other questions from the audience here, we're going to proceed to our second presentation of the day. Thanks a lot, David, for the very valuable information for us.
Can I give one final comment?
Yes.
I imagine this whole group knows this well, but I think it's very advantageous to have your own weather monitoring on site on your farm or production systems. With a full weather station, you can go as fairly cheaply from a few $100s to very complex. It's kind of your decision, but I would at least have a rain gauge, and also more and more work being done with irrigation and soil moisture sensors. So the more you can monitor your own fields, I think that puts you ahead of the game also.
Yeah, definitely. And we have shown in other research developed by our colleagues here at the University of Florida, including some projects with Clyde Fraze, the great economic advantage of monitoring monitoring the soil and temperature, soil moisture, reduction in irrigation needs, timing of fertilization and fungicide and insecticide applications and everything. It's those are great tools.
Absolutely.
Awesome. Okay, so we're going to our second talk of the day. I'm glad to introduce you to Dr. Juan Romero. Dr. Juan Romero is a friend from a long time here at the University of Florida. He got his PhD here in 2013 and is currently the dairy cattle nutrition specialist at the University of Maine. So his research focuses on factors that affect forage quality and conservation in order to develop novel additives that will improve profitability of livestock producers. And Dr. Romero recently did a great work, literature review on hay inoculants, and that is the topic of his presentation today. Dr. Romero, thanks for being here today. Welcome, and the floor is yours.
Thanks, Marcelo. Thanks for the great introduction, and thanks to all of you for hearing me today. So let me start sharing my screen. Can you guys see it now? Can you see? Yes? Excellent. So like Marcelo was saying today, I'm going to be talking about the efficacy of preservatives, both chemical and biological, for the storage of high moisture hay. So current recommendations for hay production tell us that we should strive to cure our hays in less than 3 to 5 days and achieve moisture concentrations lower than 20% for small square bales and lower than 16 to 18% for large bales. So however, like we have been discussing, this can be quite challenging in rainy areas in the Eastern US and Northern Europe, and it seems like this is becoming more of a problem. And we can see that many producers are shifting from hay production to haylage, baleage, silage production because of these climate issues. So it is important for us to be below this threshold of moisture because of the microbial activity and plant enzymatic activity that could decrease the quality of the forage if we're not to meet those levels of moisture, if we were to be above those, right? So when we're above those levels of moisture, then what we see is microbial spoilage starting to happen. So especially driven by fungi, by molds and yeast. So these microbes are going to start breaking down the bale nutrients. And because they are aerobic organisms, then they will oxidize fully those nutrients to water, CO2, and release heat in the process. So then that in turn result in our bales shrinking, in losing weight, dry matter because of that spoilage action. But it's not only that. We also have a decreased nutritive value of what is left after this spoilage process, because these microbes, they will go first for the top nutrients, for the most digestible nutrients like the sugar, soluble proteins. Those are going to be the first one to be gone. So, and on top of that, then they may leave mycotoxins behind that can hinder the animal health, and also they can pose a threat to food safety from animal food products that can be consumed by humans. So all of these economic losses and impact of health, of course, are very undesirable. And also we have issues related to people developing allergies due to handling these bales, moldy bales, and developing diseases like farmer's lung, or in the case of horses, for instance, developing hives because of exposure to moldy hay. So, and recently also it has been discussed the impact of that carbon dioxide that can come from the losses during storage due to microbial activity. That is going to be greenhouse emissions coming from the bale because of spoilage processes during storage when we have to bale above the moisture recommendations. So one important thing that I want to remind the audience is that the nutrient losses during storage and harvest are going to be interdependent and divergent, as we can see in this graph. This basically means that as we strive to get our bales drier, especially when we try to get around 15% moisture and below, we're going to just take care of the storage problem. So the hay is not going to get moldy like this, but we're going to have quite a bit of harvest losses because, as you can see, as the drier the hay is, the more harvest losses you're going to experience. So especially above 15% moisture, there are going to be some heavy losses in leaves, and leaves is the most nutritious fraction of the forage. So, and this is going to be especially an issue for legume forages or mixtures that are heavy, that have a heavy legume component. So of course, all of that is undesirable, and consequently, ideally, in an ideal world, we would like to have a preservative that will allow us to bale above this 20% moisture threshold. So in that way, we will not only be taking care of storage losses due to mold presence during storage, but also decreasing harvest losses. But this actually cannot be currently achieved by consistently and at a low cost by current preservatives. Right now, the suggestion is to use preservatives when we are forced to bale higher than the moisture thresholds are presented because of weather events, because it's going to rain, or because of logistical issues. That's when the preservatives are going to, in most scenarios, give us a return on investment of the purchasing of the preservatives, applying the preservatives. That's where we're going to observe the benefits. But hopefully, one day, I hope that we're going to be able to develop a preservative that is going to consistently allow us to bale above 20% moisture, and then reduce both storage and harvest losses, so we'll have a double win. So getting to 20% moisture and below is going to be, as we know, basically is the step in the curing process that will take the longest, okay? So it is way faster to dry the forage from 50% moisture to 30% moisture than from 30% moisture to 20 or even below 20. So as we get close to 20 and below those levels of moisture, is going to take longer and longer to cure the forage. And that is why having that flexibility when needed to be able to bale above 20%, being able to rely on a efficacious preservative is going to be ideal. So what current preservatives we have available commercially? So first we have organic acids, especially propionic acid is going to be the most commonly available preservative, the most commonly used. We also have acetic acid, which is a bit less effective than propionic acid. But the issues with these organic acids is that they are corrosive, that they are hazardous. You need to be careful when you're applying them because they can cause severe burns. But the corrosiveness on hay equipment can be quite a challenge with this type of preservatives. So consequently, many decades ago, buffer organic acids were developed. So basically what is done is to add an alkali base to these organic acids, and from propionic acid form, for instance, calcium propionate, sodium propionate, or ammonium propionate by adding an alkali base like calcium hydroxide or ammonium hydroxide. So in that way, then the preservative becomes less corrosive, but for several of these buffer organic acids, what we're going to see is a loss of antifungal activity. If you were to look at antifungal activity in the lab, in a broth with a pure strain of mold, we will see that consistently the organic acid will lose their efficacy as we increase the pH, because basically this has to do with some microbiological and biochemical processes that if anyone wants, I can explain later. But there is an interesting exception here in this list that seems to be the case, which is ammonium propionate, because it's being neutralized with ammonium hydroxide, and ammonia is basically has its own antifungal activity. So, and consequently has been used that way, anhydrous ammonia, to prevent moldiness, but it requires a special equipment for application because it's quite hazardous, can be also quite dangerous for the operary. So an alternative that was developed because of those issues with ammonia is urea. So applying urea, but then you are dependent on the urease activity in the hay to break down the urea, so ammonia can be released. And well, that is not going to happen consistently. And also we have the added problem of the ammonia reacting with sugars in forages that are going to have high sugar concentration, like cool season grasses, resulting in toxicity issues for ruminants. So then basically we have this complex landscape. So we have these preservatives, but they have their own issues. So, and on top of that, then, for instance, in the case of ammonium propionate, which is a very interesting preservative, actually, we don't have that field comparison between ammonium propionate and propionic acid. That has never been done in research. Basically, there are only a few papers from the 70s that have compared these two. And unfortunately, the experiments didn't have a statistical analysis part. So they were just comparing means, and the measures that they took were very limited. So of course, then we cannot rely too much on that information. So hopefully then in the future, somebody can compare these two in the same trial under the same conditions, which will be great to answer some of these questions that about ammonium propionate versus propionic acid. But that only applies for ammonium propionate. The other buffer salts from propionic are not going to be as effective as propionic acid because of the reasons I mentioned. So the other group are the microbial inoculants, which in theory, they should be producing some organic acids from the sugars present in the hay, and also producing some antimicrobial compounds, but their efficacy as hay preservatives has been questioned, definitely. So they're going to be, according to several publications, much less reliable than when they use as silage inoculants, because basically they're in a drier environment, they're in an aerobic environment. Those are the environment that these microbes, especially lactic acid bacteria, are not meant to be. So, but overall, what we're lacking is to have an appropriate approach to measure the effects of these preservatives across the literature, across all the papers. So to have a guideline on how they're behaving and what patterns we can see when we use them as hay preservatives. So unfortunately, there is not even a hay preservative review that has been peer reviewed in a journal, and even less, there is no meta-analysis. And that is why we decided to fill that gap of knowledge, to do this statistical tool, conduct this statistical tool called meta-analysis, which basically allow us to look across all the papers have been published assessing hay preservatives and being able to get a simplified answer out of all these experiments. So that's basically what we set to do in this case. So we collected all the hay preservative articles in the literature that have ever been published, so that met minimum quality standards for this type of analysis. So we divided the data set in chemical preservatives and microbial preservatives because we wanted to assess the effect of application rate for the chemical preservatives. So which are going to be in a different type of unit. They're going to be in percentage, weight versus the hay. While in the case of microbial preservatives, the application rates are going to be in log CFU per fresh gram, which is quite different. So that is why we couldn't lump them together. We have to analyze them separately. So this slide is very important to go over some of the acronyms that I'm going to be using in the presentation. So for the models, we decided to assess the effect of preservative classification or preservative class. And for that purpose, we divided the preservatives in the papers in the following categories. First, all the experiments they assess only propionic acid versus a control. Then all the experiments that assess buffer organic acids, and this includes single and mixed buffer organic acid preparations. Also, they were analyzed as a component of this preservative classification. Unfortunately, we couldn't, I would have liked to analyze the ammonium propionate separately, but that cannot be done because there were not enough papers. So we are limited by the number of publications too. So that is why we have to lump all the buffer organic acid papers together. Then we also have the other organic acids category, which basically are all the organic acid commercial preparations that could not fit the previous definitions that I just mentioned. So because they included other stuff that were not organic acids, so other compounds that were added to the commercial products, and that is why they were categorized separately. And then we also have the urea and anhydrous ammonia in that preservative class. Also, we consider that forage type was going to be very important to assess the effect of these factors. So we then classified the papers according to the ones that assess grass, legumes, and mixtures. We also included application rate and moisture concentration as continuous variables in the model. However, for the microbial data set, we only could fit forage type and moisture concentration as moderators because of the limited number of papers for this type of experiments. For understanding the results that are going to be showing to you, is important that it's clear that what I'm going to show you are predicted differences. And this means that basically what I'm going to show you is the difference between the treated minus the untreated. So, and I'm going to be basically repeating this piece of information in the corner here of every result slide I'm going to be presenting to you, so that's clear. Also, it's going to be in the axis. So I'm going to be mentioning basically that these are predicted differences. And because of time and to facilitate the assimilation of the information that I'm going to be presenting, I also add in this comment here for each result slide indicating that the more negative or the more positive is going to be better, right? So in the case of dry matter loss, effects observed as we apply propionic acid in increasing application rates, basically the more negative the difference is, the better it's going to be for the hay preservation, right? So what we observe is going to be that as we increase the application rate of propionic acid, we're going to see an increasing benefit in terms of preserving more of that initial dry matter. So we're going to have less of dry matter loss as we increase application rates. And basically that follows the current suggestions in terms of the benefit of increasing application rate for propionic acid. So in the case of other organic acids, and this only applies for other organic acids, what we see is that when we start increasing moisture concentration for this type of preservatives, we see a reduction in their effectiveness. So as we get to 20, 25% and higher moisture levels, they lose their benefit at preventing dry matter losses. So, and that of course is going to be not desirable because usually we're going to be applying preservatives when we are around 20 or higher than 20% moisture. So one of the most interesting results that we observed for dry matter loss was that in the case of propionic acid, because fortunately for this type of preservative, we have enough studies that assess mixtures, legumes, and grasses, we observed surprisingly, because we didn't see this before in the literature, that legumes are less responsive to propionic acid than grasses. So because the more negative, the better here. So, and we see that the grasses are getting more negative values, meaning that basically there is more prevention of dry matter losses. But in the case of legumes, that response is much more limited. So this could mean that either we need to apply more preservatives, more propionic acid for legumes relative to grasses, or that grasses will need less preservatives than legumes. However, I cannot give you a concrete answer because current commercial suggestions for preservative preparations do not make any distinctions between legumes and grasses. So for instance, these recommendations from propionic acid. So as we can see, basically, they don't make any distinctions between grasses and legumes. So basically, this is something that needs to be addressed in the future. So, and because the meta-analysis is suggesting us that this is likely the case, but surprisingly, there has never been a study that has compared an additive across grasses and legumes in the same study under the same experimental conditions. So the same soils, the same season, the same cut. That has never happened. So, and that was very surprising. So that, you know, I think this is an important point that needs to be addressed, because otherwise we may be underestimating how much propionic acid we need to apply to legumes, or overestimating the grass ones. And most people will be dealing with mixtures. So then, you know, the more legume that you have in your stand, then that means that you will have to correct your application rates too, to optimize the utilization of the preservative and to get the results that you want. So this is a very important point, I believe. So we speculate that the differences in responsiveness between legumes and grasses is because of differences in the levels of proteins, pectins, and ash, which are higher in legumes versus grasses, that are going to be basically manifested in differences in buffering capacity between legumes and grasses. So legumes have much higher buffering capacities than grasses, and this is widely known in the silage world. So this is something that basically we all know in the silage industry. So we know that acidification is more important for legume silages, but it has never been mentioned for legume hay. So, and remember that what you're applying is an organic acid. So is in the case of silage, what you're producing, you're fermenting the sugars to produce organic acids. So basically it's more or less something similar what you want to achieve. So this buffering capacity basically makes the pH, the decreasing pH harder in legumes. And basically this is a result of the organic acid being neutralized by the proteins, pectins, and ash in legumes that are present in higher concentrations, and that results in the propionic acid or the organic acid to be less in their undissociated form, which is the more antifungal. So, and then that basically explains why they're going to be less effective, we believe. So, but this needs to be corroborated in the field. Although I have discussed this with other forest scientists, and basically we believe that this is basically the most likely explanation of the results that we are observing in the meta-analysis. So the closest piece of information about comparing legumes versus grasses that we have found in the literature is this study conducted by Koblenz, which basically was comparing heating degree days, effects on dry matter recovery across alfalfa and Bermuda grass. And these heating degree days is the heating degree days of the bale. So this is like how much heat is accumulated in the bale, okay? So, and as we can see, at equal levels of heating degree days, we see that the alfalfa has lower dry matter recovery than the Bermuda grass, meaning that it has more dry matter losses, meaning that the legume seems to be more susceptible to spoilage than the grass. But again, this needs to be corroborated in the field. Visual moldiness is another variable that we evaluated in the meta-analysis. So because basically is a variable that has been measured in many of these studies, although it's a subjective variable, so meaning that it's a visual estimation, and then consequently, because it's objective, then the data set is more limited in how much we can do with it. So that is why we could only analyze the simple effects for visual moldiness. We couldn't analyze any interactions. So, but we can see that the organic acids and anhydrous ammonia are helping reducing that visual moldiness, because in this case, the more negative the differences, the better, okay, in terms of visual moldiness. For maximum temperatures reached in the bale, we observe a three-way interaction for the buffer organic acids, because basically what we were observing for the buffer organic acids is that as we increase the moisture concentration at the highest application rates, we will be seeing the greatest benefit relative to control, because remember, these are differences. So in this case, the more negative the differences, the better. So because the control very likely here, because was quite wet, 30% moisture, then heated quite a bit relative to, well, the control heated quite a bit because it was high moisture, but when you apply the buffer organic acid, then we have a great effect preventing that heating, and that is why we see a big difference here. But when we apply low concentrations, the lowest concentrations of the buffer organic acid at the same high moistures, basically what we'll see is that the preservative stop being effective and have very little difference against the control, meaning that the dose, as you can see in this graph, the dose is very important. So this dose-moisture interaction is very important, and we already are aware of that from previous experiments. This is an important point, since we're already talking about temperature, to talk about the importance of monitoring the temperature of the bales while they're being stored, to make sure that we are not going to have any issues, especially related to hay fires. So as long as our bales during storage are kept cold, so kept below 50 degrees Celsius, then we shouldn't have much problems. And we basically have to worry about the first 30 days of storage, because most of the heating in bales will happen the first 20 days. So most of that activity will happen early in the process of storage. So, and then basically the bale starts to cool down and becomes stable. So, but as we increase, we observe higher temperatures of our bales above 50 degrees Celsius, we need to start worrying about temperature damage to the bale. So for instance, Maillard reaction happening, increasing the levels of acid detergent in soluble nitrogen, which means that it's going to be less digestible protein for our animals, which is quite bad, right? So, and then when we start observing temperatures above 70 degrees Celsius, there is an increased danger of fire of the bales. So especially about 80 degrees Celsius, that's where we start seeing spontaneous combustion of the bales. And basically when we reach that point, the only thing that you can do is to call the fire department to help you deal with the situation, because it could catch fire at any time. I adapted this graph basically from University of Florida Extension Service website that I'm sharing here. So this graph has the result, the same things I presented, but in Fahrenheit, which will be more useful for people that have to deal with English units on a daily basis. So this slide I'm showing to you, you can find it here at the University of Florida Extension Service website. I'm showing at the bottom of this slide. So in regards to sugar levels, so the preservatives are helping to preserve sugars, especially the propionic, other organic acids, buffer organic acids. You can see that more sugars are being preserved when you apply them. So because the more positive differences, the better in the case of the sugar results. So, and this is important because sugars are the nutrients that will be first consumed by these aerobic microbes when we bale wet. So by these molds, the first thing that will disappear are the sugars. And basically these preservatives are helping to preserve as much as possible of those sugars in the hay. An interesting result that we observe, again, grasses versus legumes, is that we can preserve more sugars when we apply preservatives to grasses, but in the case of legumes, that is not the case. So, and that of course then is reinforcing that idea that legumes are responding more poorly than grasses to preservatives. And the same thing that we observe for in vitro dry matter digestibility. So the grasses are responding better to the protective action of the preservatives on dry matter digestibility relative to legumes. For that indigestible nitrogen fraction, what we are observing is that for propionic acids and other organic acids, as we increase the moisture levels, so the preservatives are making a bigger difference. So they're basically helping to reduce that acid detergent soluble nitrogen, because in this case, the more negative differences, the better. So we're getting that benefit, especially a higher moisture. So that's what we want, right? To be protected when we have to bale above 20%, 18% moisture, that we have that protection of the nutrients in the bale. So in the case of other organic acids, we see that increasing the application rate also helps at basically having less of that acid detergent insoluble nitrogen. So changing gears now. So let's see what we observe for the microbial inoculant experiments across the literature. Basically, the inoculants across the literature, across the studies that we evaluated, did not have an effect on dry matter loss. So they failed to have that protective action on dry matter loss like we observed in the chemical data set. So in terms of visual moldiness, we see that basically these inoculants are having a benefit, but a low moisture concentration. So as you can see, between 15, 20%, you can see the benefit, but as you increase the moisture concentration, that benefit is lost. So which is, of course, not ideal. In the case of maximum temperatures of the bale, so again, for the legumes, we see something similar. So at low moisture levels, there is a benefit, but as we increase the moisture, that benefit is lost. And in the case of grasses, basically the differences are negligible. So in the case of sugars, we also see that inoculants seem to be protecting more sugars in grasses than in legumes, like we just saw for the chemical data set. So this is going to be also consistent with the microbial data set too, in terms of that differential response between grasses and legumes. So in conclusion, overall, so those organic acid-based preservatives, such as propionic acid, buffer organic acids, or other organic acids, are all of them effective at preserving hay spoilage, but propionic acid seems to be more consistent about it, and in some variables seem to be having a greater protective effect. But this was not the purpose of the meta-analysis. So this meta-analysis was, the model was not set to compare across preservative, was set to assess the effects on individual preservatives. So which is a different approach, right? So we are basically checking the trends, the interactions, but not necessarily this tool is meant to compare them, okay? To say that this one is better than this one. That's not how it should be used. So, and remember that the best answer is actually to do the field study, and that's something they're going to be talking in a second. So in the case of some preservatives like anhydrous ammonia and urea, there was lack of studies for some variables, and more studies need to be conducted, although we have limitations in terms of these products not being very popular among producers, especially the anhydrous ammonia, because of the difficulties of its application. So, and also the risk of getting into toxic, generating toxic compounds for forages that have high sugar levels. In the case of microbial inoculants, we see small effects limited to low moistures, but as we get to levels of moisture around 25%, then the microbial inoculants stop to work. The other important conclusion is that legumes seem to be less responsive than grasses and mixtures for both chemical and microbiological preservatives, and that's something that needs to be looked at. So we need to have studies comparing legumes and grasses under the same conditions in the field to be able to answer this definitely. The meta-analysis is just giving us basically a probabilistic answer, is a model, just like the weather model is basically telling us it's likely that this is happening, okay? But we need to confirm it. It needs to be confirmed across different regions, because in Florida, there are different types of grasses, different types of legumes compared to, for instance, to the Northeast region. So that basically needs to be addressed. Also, we need to have studies comparing propionic acid and buffer propionic acid, especially ammonium propionate, properly under the same conditions and measuring all the variables that are going to be relevant. That has not been done yet. In the case of microbial inoculants, basically, we need to understand better how they work, because basically lactic acid bacteria, they don't like to be at those dry levels. So 15% moisture, 20% moisture is going to be quite dry for those lactic acid bacteria. And also they like to be better in anaerobic conditions. So the aerobic conditions of the bales are not going to be helpful, although some people speculate there are some anaerobic pockets in the bale, especially in high density, but basically that has yet to be proved. So basically that there is a lot of unknowns with inoculants. Some people say that their action is driven by the organic acid produced, but some others say that it's because of antimicrobial peptides being produced. But again, especially with the peptides, that has not been measured. So in the future, hopefully, there can be some novel microbes that can be tested because of our increasing knowledge now in microbiology is expanding. So maybe in the future, the companies can develop novel products that are going to be great. So, but that has yet to be observed. So in the case of hay experiments, it's important to note that many of them are affected by weather too. Just like in real life, when we do the experiments, a lot of papers in the literature dealing with hay preservatives basically got rain damage in the middle of the trial that kind of confounded the results. So, and unfortunately, that's something that kind of makes things kind of more unclear on what is going on. And consequently, maybe, you know, we need to refine our tools in vitro so we're able to kind of predict what's going on in the field without having the confounding factors that sometimes can cloud the results. The field studies are definitely going to be key, but sometimes we can get, you know, more clear answers or narrow down the treatments in experiment by understanding better what's going on in the lab and then translating that to the field. So with that, I'm open to questions. Basically, you know, my grad student, Marjorie Killeri, she's the one that did all the hard work in this project and basically presenting what she just defended in her thesis. So, so basically, she did a great job at assessing this that nobody has done before. I also want to thank Dr. Robin White from Virginia Tech, that was the one that conducted the statistical analysis. So if you have any questions, I'm going to be open to questions, but you can also email me to the email I'm showing you there. So, and I also want to acknowledge the funding provided by NIFA and also BASF. So with that, Marcelo, thanks a lot for letting me participate in the hay contest, and thanks to all of you for hearing my presentation.
I appreciate the presentation, Juan. Very good, very well done. It's a very important information because we frequently get asked about inoculants, inoculants on hay. So kind of a take-home message: inoculants and preservatives, not actually inoculants on hay. They may have a place, but they are not. They're not going to overcome poor drying on hay. Correct?
Yes, well, so the current recommendations is to use the preservatives when you are forced by weather or logistical issues, right? So you know there is going to be rain damage, you can apply the preservatives, and that's where they're going to maximize their economic return. So in that scenario, yes. So, but in the future, hopefully, somebody will invent a preservative that is sound and that consistently at a low cost can allow us to bail a little bit weather, right? So we can reduce those field losses, but that we are not there yet. So we are not there yet.
Well, did you changing a little bit from the perspective of hay production and going into the hay use? Any of those inoculants have effect on intake or other parameters of animal production?
So in vivo results. So we try to get some in vivo measurements in the meta-analysis, but unfortunately there are very few studies dealing with hay preservation and doing in vivo measurements like milk production or gain. So unfortunately, we cannot do that assessment, and the results are like all over the place. So like there is not concrete answer. So it's hard to tell, but logic will tell you that if you preserve more nutrients, so if your hay is higher quality, your animal will perform better, because if you see the composition, if you have less NDF, if you have more protein, if you have more digestibility, which you can easily measure, and that's reported consistently, you know, that to be benefited by the application of preservatives. So then you can speculate the animal performance will be improved, but nobody has ever done an animal study assessing that. The studies are quite old, and that's another knowledge gap. So unfortunately.
Sounds like we have a lot of research to do.
Yes, yes. So we need to convince some people that is a research that is worth, because some people will argue like, oh, that is already, you know, like that will be expected. But I think that having the hard numbers, so having the concrete numbers, like you are going to experience this decrease in average daily gain, you're going to experience this decrease in milk production, will be quite helpful. So especially for those producers that are relying a lot on rations that are heavy on hay. So those organic producers, we have quite a bit of them in the Northeast. So in the winter, they have to rely a lot on hay. So, and then, you know, then it becomes important.
Yeah, that's correct. For Florida, it's interesting because we do have conditions that should allow us to produce forage year round, but in an average sense, but getting established cool season forages sometimes is tricky, and people do rely on hay production a lot. And then we get our summer here where it's raining all the time. So there has been a push towards going to haylage. So wrapping those bales as an alternative, which can also be something interesting.
The issue I see with that, which is a great alternative, the issue I see with that is the marketability. So because hay can be moved across states, even across the ocean, and there is quite a bit of hay export into Asia. So, but silage, I mean, moving silage is quite hard. So then, you know, I think that there is a factor, there is a effect on the forage markets that we are not measuring, you know, that reduction of hay availability because of this climate change and people having to produce more silage than hay, then that will definitely have an impact on the forage market, because the forage market is really only hay. So, so if you have a reduced pool of hay available, then when, you know, there is a scarcity of forage for XYZ reasons, then that's going to result in higher feeding expenses.
That's correct. So do we have any questions from the audience here? Otherwise, I'll keep asking you questions, because I have many things I want to know more here. So a while ago, I gave a presentation on some tools in hay production, and I was surprised by the low amount of reports, papers, or even other reports in the literature talking about hay moisture testers. And this was one of the central topics of your work. Do you have any advice regarding hay moisture testing? What testers are good or not, or techniques?
So the best tool to measure hay is going to be the coaster in the field if you don't have an oven, because most people will not have an oven. So some people can use also an air fryer. So as long as you get that hot air. The problem with microwave and hay measurements is the microwave will be very easy to catch fire. So doing hay moisture measurements in microwave is not recommended. There is a high risk of, you know, catching fire. During the process. So you have also these hay probes that basically estimate moisture from an electrical gradient. So you can find those in Amazon, but those are basically unreliable. So they're not reliable. So, and well, recently the NIRS technology has been developing. So there are some tools out there to measure moisture that are based on that technology, some portable devices. But basically, as far as I know, they are limited to silage right now. And there are quite a bit of people that depending, well, it depends on the brand you're talking about, some people will say that some brands do not have the good predictability, so they're not accurate, but that's a different conversation. So basically at the end, coaster, having a coaster or an air fryer, which is basically like a coaster, so will be the most ideal when you will want to measure moisture in hay, if you don't have an oven, right?
Yeah, correct. So for those that are attending our seminar, our field day next week, we're going to talk a little bit about those moisture testers and how we those coaster and microwave, and also the air fryer.
Yes, and it's important, that not only the tool or how to do that matter, but the samples that you're collecting. So anyone that has had to measure moisture on a windrow to decide when to bale, will know like the difficulties of, like how representative is being representative, like how, grab it all the way from the floor, like that noise there. Of course, the more material you grab, the better. But then when you do the coaster step, you can only put 100 grams. So we can put more, but it's going to slow everything. And well, anyway, so, but then, it is important then if you have any way to reduce the particle size of that sample, so to process it, to chop it. So, and then basically being able to collect the material that is coming out, all of it, because especially when you get dry, you will be a lot of leaf powder coming out, right? So there are some chippers that are able to do this without, having too much damage on the leaves. So and then you are able to mix everything much better and get a more accurate measurement. Because otherwise, it's very hard, like to even know, like if your sample is representative or not. So reducing that particle size so you can mix and then take a subsample is super important. Yes.
Perfect. Good. Very good. Very good information there. Zierden, have any question from the audience here? Well, if Juan, do you mind unsharing your screen? I just want to share a few slides at the end here.
Yes, let me. So I'm trying to look for my Zoom controls. Where? Oh, here. Good.
Perfect. Okay. Well, everybody, thanks a lot. We are concluding our section today. I appreciate the participation of everybody. Thanks, Juan. Thanks, David, for the presentations. Fantastic presentations and a lot of good information here. I'd appreciate if you can leave us a comment and a feedback before you log off today. I think Zoom is going to send you to take you to a different screen where you can take a quick survey. I promise it's not going to take more than 1.5 minutes, 2 minutes to go through it. Just want to give a shout out to our sponsors. So the Southeast Hay Short Course is presented by the Southeastern Hay Contest in partnership with Massey, Ferguson, and is initiative promoted by UF-IFAS Extension, Alabama Cooperative Extension, and University of Georgia Extension. Our collaboration partners are Florida Gateway Fairgrounds, Hobo Tractor, and Mayo Ag Services. Associate sponsors, Purina and Farmers Co-op that sponsor our last talk, and Farm Credit of Florida, who will be present in our field day next week. And our trade show sponsors, Corteva AgriScience, AgriKing, Key to Profit, and Cardin Insurance. So thanks a lot, everyone. And I hope to see some of you next week. For the others, I hope to see you some other time on our virtual land here. Thank you, everyone, and have a good evening.